Here we are at the top of page 4 for 7.6, and at this point in the notes we're going to talk about what you're going to see when you get to the practice plus section, which, as you've noticed as you've gone through the problem sets, it's kind of like two problems in one. They're combining some skills here. So let's look at what it might look like. What if they showed you something like number 62, y cubed plus 2y squared minus 3y equals 0. Again, a great way to start when you aren't sure what to do. If it looks really different than what you've been used to or getting better at as you go along, what's so different about this one? Well, to me what stands out right away is there's a y involved in each one. It's not a quadratic equation. You've got a y cubed here, and we said that a quadratic equation would always be x squared plus an x squared piece, an x piece, and a constant piece. So what do we have here? Well, it's in the section, so we must have the skills to be able to tackle this. So let's see what we could do here. Let's follow our steps. The first step says to rearrange and get it to standard form, equal to 0. Well, it's equal to 0, so we've got that taken care of. Our next thing was to factor. And in factoring, we ask ourselves two boring questions, but it makes us really good at factoring. Is there a greatest common factor, and how many terms after we pull out a common factor? In fact, there it is. It does have a GCF. There's something that all three of these have in common, and that is y. So let's pull that out here. Yes, it does. We pull out a y, leaving behind y squared plus 2y minus 3. If we were to redistribute that y, we'd get back to our original. So y cubed divided by y is y squared. 2y squared divided by y is 2y. Negative 3y divided by y is negative 3. And of course it's still equal to 0. So we've done our GCF. How many terms are left? And now we're focused on what's left over here. There are 3 terms left. So I'm just going to go ahead and make sure that my GCF still shows up. We want to bring that down and not lose track of it here. So I'm just going to bring it down a couple steps and make sure it shows up in each place. So in fact, maybe I'll just help myself out here and put it in a couple different places to remind myself. Because what I'm trying to do now is factor this piece right here, the y squared plus 2y minus 3. And so I've got an a value of 1, b value of 2, c value of negative 3. Some of you who are getting really good at factoring will start to realize when there's just a value of 1 here in our a value, we can go ahead and just start playing around with what goes inside of here. We can put y and y. We know it's going to split to y and y, and now we just have to split negative 3 into something times something that will give us negative 3, but then when we do the outside inside, it will add up to give us the positive 2y, or in this case subtract, because one of them will be negative. So whichever method you use, kind of a guess and test or whatever, you should in the end up with these factors, y plus 3 and y minus 1. And again, the whole thing is still equal to 0. We're just bringing that down. Okay. And I'm not really going to do all the different factoring here. We just want to get to the point where we're practicing the zero product principle. And I'm hoping that you're getting good enough at factoring that it's going fairly smooth and quickly for you. If not, if factoring has not sunk in yet, please come to class, please get some extra help, or go to your help resource, whatever that may be. Now, we are finally at where we have everything in multiplication, everything's in factored form. So we actually this time have something times something times something. 3 somethings multiplied together equals 0. We can still use the zero product property. I'll start to abbreviate here, zero product property, ZPP, to say, hey, if I've got everything being multiplied here, I can say, well, either the first something equals 0, or the second something, in this case y plus 3 equals 0. First something was y, second something is y plus 3, or the third something, y minus 1 equals 0. There are actually 3 possible answers here. When you solve this, of course you just get y equals 0, y equals negative 3, and this third one is going to be y equals 1. Remember earlier I said at the most we're going to get 2 answers? Well, that was because we were in quadratics. Notice that we started with a y cubed. Now we actually do have the potential to be able to get 3 possible answers, and that's what we ended up with. You can check all these in the original. You put 0 in, you get 0 plus 0 minus 0 equals, that's true. You put negative 3 in, you get negative 27 plus 2 times negative 3 squared is 2 times positive 9, that's 18. So negative 27 plus 18 plus another 9, negative 3 times negative 3, so that all equals 0. Put in 1, you get 1, plus 2 times 1 is 2, minus 3 times 1 is minus 3, so 1 plus 2 is 3, minus 3 is 0. They all work. So we've checked, the fit is good. We can wrap up this present nice and pretty in our set notation. 3 answers, negative 3, 0, and 1. Typically, you want to go from least to greatest here, so we've got our negatives, then our 0, then our positive, but don't worry too much about that just yet. Just wanted to plant that seed there. And then as we look at the bottom of the page, just got some highlighted reminders that are in this section of the book here. On page 455, they've got the definition of a quadratic equation, and that's that idea that it's a second degree polynomial set equal to 0, or standard form is set equal to 0. You've got the zero product principle, that's also on page 45, which is a reminder that if you have something times something equal to 0, then either the first something or the second something equals 0. And finally, on page 456, just the steps for how to solve a quadratic equation. Rearrange it as necessary, factor, set each factor equal to 0, solve those equations, and then check in your original. So just a good review of what the book provides in terms of how they write out the steps.